Okay, let's talk about naming conventions. Every word will be capitalized. So, for example, the dog, or this is camel case. Type names will be prefixed with T, U, A, S, I, and F. Template classes are prefixed with T. Classes that inherit U object are prefixed with U. Inherited from actor are prefixed with A. SWidget, which are slate objects, are prefixed with S. And classes that are abstract interfaces are prefixed with I. Most other classes are prefixed with F, though some subsystems use other letters. Any variable, method, or class name should be clear, unambiguous, and descriptive. The greater the scope of the name, the greater the importance of a good descriptive name. Also, avoid over-abbreviation in names. All variables should be declared as one at a time so that a comment on the meaning of the variable can be provided. All functions that return a bool should ask a true-false question, such as is visible or should clear buffer. All Boolean variables must be prefixed with B. So, for example, B pending destruction, or B has faded in. A procedure or method, which is a function with no return value, should use a strong verb followed by an object. An exception is if object is the method is an object it is in, then the object is understood from context. Names to avoid include those beginning with handle and process. These verbs are ambiguous. Though not required, I and Epic Games will encourage you to prefix function parameters names without if they are passed by reference and the function is expected to write to that value. This makes it obvious that the value passed in this argument will be replaced by the function. We'll go over parameters and functions later, but just kind of keep that in mind. Also, functions that return a value should describe the return value. The name should make clear what the value of the function will return, and this is particularly important for Boolean values. So, continuing on, let's look at the portable data types. Now, this is going to look like a lot of stuff, but just bear with me, we'll get through it. So, in computer programming, the computer understands ones and zeros. It understands bits, and bits are a two-state device, either a 0 or 1. And a byte is 8 bits, so you'll have 8 consecutive ones or zeros, and that makes up a single byte. So for numbers 0 through 255, so actually, before we actually get into the data types themselves, when you're programming and creating variables, you need to think about what value it may hold so that you can allocate the proper amount of memory. If you need a value of 256, it is impossible for you to store 256 in an unsigned integer of 8 bits. Or 1 byte. You'll have to use an unsigned 16 or a regular signed integer of 16. So, what is the difference between a signed and unsigned integer? As you'll notice that there are two sets of categories of variables allocated here for us. Well, an unsigned integer is a 0 through a variable number. So, for example, an int 8, which is allocating 8 bits of memory, you can go 0 through 255. For unsigned integers of 16 bits or 2 bytes, you can go through 0 through 65,535. For unsigned integers of 32 bits or 4 bytes, you can go from 0 to 4,294,967,295. For an unsigned integer of 64 bits or 8 bytes, you can go through this number. I have no idea what that is. It's huge, and I have actually never seen something that large before in my entire life. So unsigned integer of 64 bits is quite a large number. So the difference between assigned and unsigned is negative and positive. So if you need a negative number, the amount of memory that we're able to be utilized is essentially the same, except that we have to divide in half our 255. So from an integer of 8 bytes signed, or 1 byte, that's from negative 128 to 127. With a signed integer of 16 bits or 2 bytes, that's from negative 32,768 to 32,767. Now with a signed integer with 32 bits or 4 bytes, you can go from negative 2,147,483,648 to 2,147,483,647. Now, a 64-bit or 8-byte signed integer can go from this negative value to this positive value. It's quite a bit of information. Now, a Boolean is a single bit. It only stores a 0 or 1. This allows us to utilize Boolean logic, which we'll get into a little bit later on, but essentially a bool is a single bit. You can have 8 booleans in the same space that you can have an integer of 8 bits and an integer unsigned of 8 bits. Now, when we talk about real numbers, this is going to seem a little complicated because we're gonna go over this, but don't fret. It's very, very simple. So essentially, a float is a 32-bit or 4-byte number with 7 significant digits of precision. What is significant digits of precision? That means the amount of digits to the right-hand side of the decimal place, you have 7 available slots. So a double is a 64-bit or 8-byte number with 15 significant digits of precision. Now let's talk about floating point information. When we have a 32-bit number or 4 bytes, this is essentially a 32-bit number. This 32-bit number means this. So let's kind of go over let's kind of dissect this 32-bit float, okay? Our last bit from the left is the 31st bit, and that is the sign bit. This tells you if the number is positive or negative. If it's 0, it's positive. If it's 1, it's negative. The next 8 bits from number bits 30 to 23 bits, this is your exponent. And the next 23 bits from 22 to 0 is your fraction or other people call it a bit index. Now we're not really going to go into this. I just kind of wanted to show you what a floating point number looked like in memory. Now, getting to tcars, these are a character, a single character. You should never assume the size of tcar because essentially I believe it is a 8-bit number, but if there are other characters that are used that might be larger or smaller than 127 or negative 128. Or rather, I believe it's a unsigned integer, so it'll be 0 through 255. There are characters that may be 256. So this is why you never assume the size of that, because it might not be what you assume it will be. Now, ptr int is a pointer to an integer. It is an integer that may hold a pointer. You should also never assume the size of this. We're not really going to talk about ptr ints, but I just wanted to go over it because it is something that is seen. We'll talk about pointers later on, but for right now, a pointer is essentially a variable pointing to a specific memory address. So you can think of memory like a street. There are specific addresses, and those addresses hold certain people or data. When you point to the address, the person living there or data that is living there might not be what you expect it to be, so you're able to point to the specific address and monitor its value as it changes throughout the lifetime of the program. You can also, variables that are set to a specific value, that's actually pointing to a specific name of the address. So it might not be at the same address all the time. So there's a difference between a pointer variable and a variable. A pointer variable will point to the address of in the memory, and a variable will point to the actual value